Okay, now picking up on using piecewise defined functions and finding limits. And you'll notice that this function right here is the same as the function we just graphed, and we will come back and look at this graph in a minute. Okay, so find the following limits for f of x equals, and you see the function there. So our first limit here says x approaches -1 from the left. So really important to remember is what this notation means. X approaches -1 from the left means that x is close to -1 but less than -1. So now I go and look at my restrictions. When I am less than -1, I'm going to use the rule 2x plus 5. So the first thing I do is replace the symbol f of x with the appropriate rule to be used. And so in this case, I'm going to use the rule 2x plus 5. And then once I've made that decision, all I have to do is substitute. And I get 3. Similarly on the next one, what this symbol means right here is that x is close to -1 but is greater than -1. So we will use, and I go and look at my restrictions, and my restrictions say if x is greater than -1, I should use x plus 2. So the first thing I do here is replace the symbol f of x with the appropriate branch of the function, and then again, just substitute. Then we get to the two-sided limit. And so we have to remember here that really important fact we had from several videos ago. That really important fact that a two-sided limit exists if and only if both the left and right limits exist and are equal to each other. That they both exist and are equal. Well, the left limit was 1. The left limit was 3, the right limit was 1, so the two-sided limit does not exist. And that is because left did not equal right. Now I have another one thrown in here just kind of for fun on the end. X approaches 5 from the right. And when I throw these sort of things in, students try to make this problem just as hard as it was about -1. Notice this function really doesn't care too much about 5, but you still have to think about it a little bit. X approaches 5 from the right means that x is close to 5, but on the right. That's not how you spell the right. And so I'm going to use x plus 2. So I still decide what branch of the function to use, and it's still going to be x plus 2. Didn't need that equal sign there. And I would get 5 plus 2, or 7. And note, even if the right limit hadn't been there, x approaches 5 of f of x, that just means x is close to 5. So I'm going to use x plus 2, because 5, and can't get the whole thing at one time, when I'm close to 5, whether I'm close to 5 but on the right, or just close to 5, those all fit into the category of greater than 1. greater than negative 1, excuse me. So regardless if I was doing x approaches 5 from the right or just x approaches 5, both of those mean I'm really, really close to 5. When we talk about close to, we mean really, really close. And when I'm really, really close to 5, I am certainly greater than negative 1. So in each case, I'm going to use the x plus 2, and in each case, get 7. So there's the answer for 5. And I just like to throw that in there because sometimes students will try to, if I throw in a number that really isn't kind of quote-unquote important, they make it really, really hard. Here, 5, I just use the x plus 2 no matter what because 5 is greater than negative 1. Now looking at these guys and going back and looking at the graph that we did, if I can find the graph we did. Can we get these all on the same page? Yeah, that works pretty well. So x approaches negative 1 from the left. So you would be using the pink line because that was what we did when x is less than negative 1. So when I use the pink, yep, it looks like my limit is 3. Remember, your limit values are on your y-axis. So as I follow that pink graph up until its end, its y value is close to 3. So that corresponds with the left. On the right, we said the answer was 1. The right was the yellow line. So if I trace the yellow line closer and closer to when I get to 1, my y coordinate, or closer and closer to x equal negative 1, my y coordinate is at 1 again. So both of those, the graph verifies what we saw in the limit. The left limit was 3. I follow the pink line, which is the left. It ends up near y equals 3. The right limit was 1. I follow the yellow line, which was the right. Its y value ends up at 1. And then the two-sided does not exist, and we see the graph breaking apart into two very distinct pieces with my fingers not being close to each other. It's okay if my fingers you can have a two-sided limit if they almost meet, but these guys aren't almost meeting. There's a clear jump there, so no two-sided limit. So again, the limits predict the graph predicts the limits. Okay, next one, same idea, new function here. F of x equal x plus 2 if x is greater than or equal to 1, 3x if x is less than 1. So, this starts out with a two-sided limit. And most people will start and just do the problem. But I can't start with the two-sided limit. So because, that's not what I want to write first. This is a two-sided limit. And because the function is, and this is not a particularly good math word, sensitive, I think that's how you spell sensitive, to left, right of 1, we must do left, right limits first. So we can't just launch in and do the two-sided limit because the function is very, very sensitive to less than 1, greater than 1. So if you're doing a two-sided limit and two-sided limits say, hey, Ed, you can do anything, we can't do anything because the function says if you're greater than 1, do this. If you're less than 1, do this. So we have to be smart enough not to start with the two-sided limit. We have to be smart enough to look at it and say, look at that function. Gee, that function is sensitive to left and right, so I'm going to have to do left and right limits, which is what we will do on the next video.